Okay. Every time. All right. Can you guys hear me okay? See me? Everything good? Sounds good. Sounds good. All right. Well, shoot. Welcome back. We made it, sort of, at least back to math analysis in some way. Been a while since until what, the Tuesday before spring break. So a lot of stuff happened since then. Um, I'll talk more at the end about like what, just kind of general, like what the heck is this going to be like, and what is school going to be like, or PFAs, performance tests, things like that. And then just kind of I'll answer any questions you might have. I'll give you as much information as I can, at least as far as I know, and then and we can talk more after that. But perfect. Yeah, that's ideal. So yeah, but for the moment, let's jump into some math analysis. So for those of you first or math analysis kids, I guess, if you haven't, like Phoebe, been just kind of lingering in any other classes because you love math so much, if you have a question, just alert me somehow. I know it's a little hard because, one, from when I record it to whenever you get it, there's anywhere from like a 3 to 8 second delay depending on internet connections and things like that. And so you're already a little bit behind of what I'm actually doing in real life. So I'm technically from the future. And then also I know it takes a little bit to like type out a question rather than just raise your hand and say it. So if you do have a question, just alert me somehow in the chat by just typing the word question or wait or hold on or something short and quick that you can just type, and then I try to keep my eye on chat as best I can, and then I'll know that I need to pause and wait for whatever your actual question is. So it's been working out okay the rest of the day, I think. So just do something to get my attention, and I'll do my best. Okay. Okay. Also, just if something goes wrong, like if you can't see the video anymore, or you can't hear the sound anymore, or it freezes or something, just put it in the chat, and I should be able to still always see the chat, even if something else breaks. So then I can know to fix it. Right. Cool. Let's do it. So hopefully you got these blank notes this morning from me. I hope that's true. So that'll be my plan, is I will send out stuff in the morning to you, and all the blank stuff, and then you can come watch it on the stream to get the actual notes, or do it on your own time with the YouTube channel, because I'll upload videos there. But this would be the best way to do it in real time. I don't think you have much else better to do, maybe, but I doubt it. So let's do it. So we left off talking about exponential growth and decay, and we talked about the Newton's law of cooling, and hopefully that activity went well when I wasn't there, where you guys had to solve that murder mystery. Good times. And figure out all that stuff. So hope that went well. But so just a quick refresher for our warm-up question today. A bank account compounds continuously, right? The interest rate is 2.1%. After 5 years, the account has $6,400 in it. How much money was there when the account was opened? All right, so a quick first note is that while this is a compound interest problem, it does say compounds continuously. So whenever we talked about compounding continuously, we do want to use this formula, just the general exponential growth and exponential decay model formula. Okay. If it talks about compounding like monthly or compounding weekly or compounding quarterly or something like that, that was when we would use this particular problem. Okay. Or you guys can't see that. Shoot. Let me move it. Okay. That was when we would use this formula, okay, the compound interest formula, for if we're talking about it compounding, weekly, daily, monthly, yearly, something like that, annually. But if it talks about continuously, then we're going to use just our normal continuous growth and decay model, which is that one that I circled up at the top. Right. So this problem is actually a little bit different from what we've ever done before. We've used the problem, we've found different things, but I don't know that we've ever solved for how much money was there initially. Okay. So interest rate, 2.1%. So I know I want to use that as a decimal, 0.021. After 5 years, the account has $6,400. So I know that whatever the equation is, if I plug in 5, I know that I'll get 6,400. So the question becomes, though, what is that starting amount? Okay, what is that a sub 0, the initial amount of the problem? So let me first go through and just plug in everything that I have so far. Okay, so I don't know what a0 is. E is E, K, 0.021, and T. Right, this is just all the information that I have at the moment. I want to solve for a0, but at the moment I only know that if I plug in 5, I'll get 6,400. But that's still useful. So let me go ahead and do that. If it would let me scroll down. Oops, not T. So I know if I plug in 5, I'll get 6,400. Now, in order to figure out a0, now usually we're used to like dividing and using natural log and then dividing again to solve for either k or to solve for t, but we don't need to do that right now. We don't need to solve for k. We don't need to solve for t. The question is just how much was there initially? So I want to take a look at this, right? Now, this is, not the prettiest thing in the world, but it is still just a number, right? E is just a number, 2 point something. So a number to the power of some other number is going to be a number. So basically what we have here is a0 times a number. Well, if I just want to get a0 by myself or by itself then, just so I can solve for it, well, if right now it's being multiplied by all that other crap, then just like in our normal solving, I'll just divide then to get rid of it. So let's divide. We'll divide that on both sides. That way that will cancel. And I get that a0 equals something. So here's where we got to calculate. Usually I can just rely on you nerds to do the calculations for me, and then we can argue about the decimal places, but I guess I will actually do some calculations myself, even though I don't like it. E to the 0.021 times 5. that should be 5762.08. Okay, now typically I'd round to 3 decimal places, but in this case, rounding to 2 because it's money. Right? So initially, we would have started with $5,762.08. After 5 years, it would grow to $6,400. So a little bit different style. Again, I don't think we've had a problem yet where we've solved for initial amount, but here we have it. Just a quick recap then of those problems. Right. So the continuous growth or decay, and then the Newton's law of cooling problems that we left off working on, pretty similar, just a slightly different formula since it incorporates the temperature of the surrounding area as well, and the temperature of the thing. All right. Logarithms. Continued. So we talked a little bit about logarithms before, just in how to use a logarithm so that we could solve an exponential, right? So that we could use natural log to get rid of e or something like that. So let's go back and talk a little bit more about them though. So a logarithm would look something like this. Log base a of x. A is what we would call the base. Just like exponentials, logarithms have base. So log base a is how we would say this. Log base a of x. And then for a graph, so I'm not going to graph logarithm just yet. I'm first going to graph, if you remember, (0, 1, 1a, negative 1, 1 over a. Okay, this perfectly drawn graph is what an exponential function would look like. And so logarithms, one of the key pieces about logarithms is that they are inverses of exponentials. So we've mentioned that before, and that's the whole reason that if we want to get rid of e, then we have to use natural log because those are inverses of one another. Okay. But if you remember going back when we talked about inverses before and just general functions, an inverse and its a function and its inverse, if I graph them, are reflections. And they're reflections over the line y equals x. Right. I hope that yellow shows up okay. Just let me know if you can't see that. But if I want to graph an inverse, so I take any points and I just have to flip the order, right? If I know points of a function, the inverse function is just switched. So instead of 0, 1, there's 1, 0. Instead of 1a, there's a1. Instead of negative 1, 1 over a, I have 1 over a, negative 1. All right, it's just kind of a rough sketch, but should work out. And I nailed it. I hit all the points perfectly through the center of them. And we can see that it has that nice reflective quality across that y equals x line. And so this purple line is actually the function, what logarithm would look like as a graph. Okay, the blue line is an exponential, but the logarithm then is that purple reflected version. Logarithms have a vertical asymptote at x equals 0. The domain anything greater than 0, since we can't cross that vertical asymptote. And the range, all real numbers. And we can see that illustrated by our graph. The y values, it will continue going down forever into all the negative y values into infinity. And then towards the top part where it starts to curve off, it is still going up though. So also all the positive y values up into positive infinity. So far, the interaction is just as riveting as teaching you guys in real life. This is, whew, man, you guys don't disappoint. So some properties and stuff that we can use. Change of base is used to calculate a logarithm that we're not, it maybe has a different base than something we're used to, something we can't just calculate in our head, something that makes it easier for us to type in on a calculator, kind of some various uses that we'll see, but it is this. So log base a of b, so we can rewrite this in different ways. So first off, I could change this into, say, natural log of b, natural log of a. So the important thing to note here is that whatever was originally inside the logarithm, right, is then what's inside the logarithm on top. And whatever the original base of the logarithm was, is now the what's inside the logarithm in the denominator. Okay, so I could, for instance, change this to natural log of b over natural log of a. Now, it doesn't stop there. It's not true for just natural log. It's true for any logarithm. So we could also do this with, let's say, common log. So common log of b over common log of a. But same thing. Whatever was originally inside the logarithm is what stays inside the logarithm in the numerator. Whatever the base of the original logarithm was is now what's inside the logarithm in the denominator. Okay, so you can see that pattern staying true, even though the logarithm changes. Right? But I mean, the point is we can change this to any logarithm we want. Right? If I really, my favorite number is 137, I could change this to log base 137 over log base 137 of a, as long as same pattern. All right, and I could keep going. I could choose any base of logarithm that I want. It doesn't matter. right? And it'll still, all of these would give me the same exact answer if I typed them into a calculator. So a quick example, let's say I want to know what is log base 3 of 29. Log base 3 of 29. Well, first off, I asked myself, is this something I can do in my head? Is 3 to some power equal to 29? No. 3 to the third power is 27, but not, close, but not quite close enough. So I can't do it in my head. It's not a natural log or a common log. So, the thing we like about our calculators is that they have an ln button or they have a log button, which is common log. But it's not either one of those either. It's log base 3. And log base 3, there's not a button for. Now we could figure out how to type it in, but it's kind of longer and annoying. So let's instead just say, all right, well, this would be the same thing if I did natural log of 29 over natural log of 3. All right, I can type that in really quick. Natural log 29 divided by natural log of 3, 3.065. Again, typically rounding 3 decimal places, just so you guys can argue about it. All right, someone asked Will what he got. All right, to reiterate, same answer if we had done common log of 29 divided by common log of 3, we would get the same exact answer, or any base log, just as long as you keep this pattern consistent. What was inside goes inside on top. Whatever the original base was goes inside on bottom. Just let me know if you have any questions. Some general properties. These are things you've talked about in Algebra 2. Maybe actually, probably not in trigonometry. But are properties you talked about in Algebra 2. So let's just kind of refresh on them. So first off, that very first property, if we see that there is multiplication going on inside of a logarithm, then what we can do is we can split those pieces up into their own individual logarithms by adding those two logarithms together. Okay, so if we see multiplication inside, we can split it up with addition between. Similar, but with division. Okay, I see division inside of a logarithm. I can split that up so that they're in their own individual logarithms. Right, but there's subtraction in between. And another important part of this one is we have to make sure the order is correct. So whatever's in the numerator originally, that's the first logarithm of the difference. And whatever was in the denominator then has to be inside that second logarithm, the thing that's after the minus sign. And then last piece, if we have let me use a different color. If we have some coefficient of a logarithm, then what we can do is move that coefficient up into an exponent of the logarithm instead. Okay, so it's a nice little property that we can move back and forth between. And then the last thing is just to remember that all of these only work if we're talking about these being the same exact base. Right? Whenever I take this first logarithm and if I split it up, the bases of those two that I split have to be still the exact same. If the original base was 3, then the bases of these two logarithms have to both be 3 too. If the original base was 11, then the bases of these logarithms after I split it up have to be 11 as well. Okay, it has to stay the same throughout. Can't change. So just a couple properties, and these will be super useful to us in types of solving, right? There'll be various equations that we need to solve that we are going to need to use these properties. However, let's first just practice using the properties themselves. So we're going to do two things. First of which is what we'll call expand the logarithm. Okay, expand, we can think of as splitting up the logarithm, right? Kind of breaking it apart and tearing it up as much as we can. So just using all my properties. Now, before I start using my properties, always check to make sure that you don't first need to do some simplification inside the logarithm. Because if so, it can make your life easier later on. Now, you can simplify at the end or at the beginning, but it's probably better just to do it at the beginning, get it out of the way, and then when you're doing all your properties, it's much better, much quicker. So, for example, I'm seeing here a y to the fourth over y, which I know I can simplify. And I'm also seeing 2 over 2, which I know I can simplify, right? Thanks to my immense math skills. I went to college, you guys. Okay, I'm really good at this stuff. All right, so I know that 2 over 2 is 1, right? I know you guys don't know that, but I do know that. Okay. The x in the numerator is just going to stay x. I couldn't do anything with that. Y to the fourth over y. So remember, our exponent rules means we subtract the exponents. So that would be y cubed. And then in the denominator, there's also still just that z there. Don't forget about that z. We couldn't do anything with the z, so it is still just there as well. All right, so this already looks a lot better. So just make sure if you're doing a problem like this, go through, split things or simplify some things if you can, and it'll help out a lot. From here, I see many things going on. I see there are exponents. I see there's multiplication, x times y cubed. I see there's division, the numerator and the denominator. When you're expanding, probably a good idea that if you can, after you simplify, first address division. Okay, I think that's the best bet. First, just split up the numerator and denominator. So I know that thanks to my properties, I can split that up into the numerator, xy cubed, minus log base 4, because it has to be the same base. It stays the same. Log base 4 of z. So that was the first split. And I made sure that the numerator was inside the first logarithm and that the denominator was inside the second logarithm. Right? That's how the property works. Now, I'm looking at this first logarithm that has the xy cubed in it, and I'm saying, okay, x times y cubed, I can split that up as well. We know when there's multiplication on the inside of the logarithm, we can split it up using addition. So log base 4 of x plus log base 4 of y cubed. And then the minus log base 4 of z just comes along for the ride. So I've split up everything I can in terms of multiplication and division. So now I'm going to look at my exponents. All right, say if you're expanding, save your exponents for last. All right, so like that y cubed, I didn't want to do anything with that cubed until I get down to my last steps, until the y cubed is all by itself, inside the logarithm at least. So now, just as a final step, in that last property we talked about, we know we can take this exponent and move it down in as a coefficient. So log base 4 of x plus 3 log base 4 of y minus log base 4 of z. And there's nothing more that I can do to expand this or split it up. So that's just where my final answer is. So that all that's left inside the logarithm is just a single variable, just an x inside, or just a y inside, or just a z inside. So the other option of what we'll do is we'll just go in reverse. So instead of taking one logarithm and splitting it up into as many pieces as we can and expanding it as far as we can, we're going to take several logarithms and then try to combine them all together into one. We're going to condense it, make it as small as we possibly can, right? So we're going to try to put these all together into one single logarithm. So for condensing, the first thing I'm going to do, people see this and they freak out. And they look at this term and don't know what's happening. Oh my gosh. There's a log base 5 of y. It's over the 3. Mr. Bonus, you didn't tell us what to do whenever there's a log in the numerator compared to the denominator. Whatever, it's fine. We're okay. So to help you out, so you can stop panicking, so I'm going to leave that first one the same. Dividing by 3, for example, if I had x over 3, that's the same exact thing as if I said 1/3 times x. You can't see that. Oops. Right. So like that. X divided by 3 is the same thing as 1/3 times x. Right? I know, everyone's scared. I get it. Mostly because of your username, but maybe other reasons as well. Maybe math reasons. So I'm going to rewrite this as 1/3 log base 5 of y. Plus 4 log base 5 of t. Okay, so if you see a big fraction like that, just make it a coefficient. It's fine, like 1/3 or whatever. So we're going in reverse now. We're trying to put things back together instead of splitting them apart. So I'm going to go through and take all of my coefficients and move them up into exponents. All right, remember back here on our last question, our very last step was to take the exponent and move it down. So since we're going in reverse now, we're going the other direction, then my first step is going to be take those coefficients and move them up. So log base 5 of x squared minus log base 5 of y to the 1/3 power plus log base 5 of t to the 4th. Take the coefficients, make them exponents. No big deal, right? Then you have a couple choices. I would say just move left to right. So I'm going to first look at, we can only combine 2 at a time. So let's just go left to right, combine the first 2, and then the next 2, and then the next 2, and then the next 2. It's it's a decent system to go about it. So since it is subtraction between the two logarithms, then whenever I combine them together, I know that means the stuff inside will be divided. So x squared, y to the 1/3. Red plus log base 5 t to the 4th. So now I just have two logarithms left. They have the same base, so I can go about combining these now, condensing them. So since it is addition going on between the logarithms, then whenever I put these two things together inside the logarithm, they should be multiplied. Okay, well, if you need to, think about t to the 4th as t to the 4th over 1. Since we have a fraction in one logarithm, it might help you to think about there's a fraction in the other one as well. Because when we multiply fractions, it's just numerator with numerator, denominator with denominator. So x squared times t to the 4th. That's just x squared t to the 4th. Y to the 1/3 times 1 is just y to the 1/3. All right, so I've condensed this all together into one single logarithm. So now I'm going to do one tiny more thing. And that is I'm going to look at this y to the 1/3. Okay, this is just more so just so you're aware, because it's hard to say. Some answers might stop at that last line that we just did. Some answers might go further, like if we're talking about a PFA or ACT, or things like that. So I want to go ahead and show you. Remember that y to the 1/3 is the same thing as writing cube root of 3. Right? Remember that when we have any fraction of an exponent, that bottom number goes on the root, and then that top number can be an exponent either outside the root or inside the root. So in this case, the 3 1/3, so y to the 1/3, so the 3 is in the denominator, so that goes on the root. The 1 is in the numerator, so that goes on the outside. I mean, to the first power is just the same thing, so that's why I didn't write the 1 out there. But so I'll go ahead and write, instead of y to the 1/3, I'll write cube root of y. Again, just so you have practice and are used to seeing it both ways, because you never know how a multiple choice answer might show up. Okay, it could be in either form. But once we do that, we're locked and loaded. We're good to go. This would be my final answer for condensing the logarithm, trying to combine it as much as I can, all together into one single logarithm. Let's see. Okay, so one more here. Just further practice. Right, expanding. And again, you don't have anything better else to do you? I doubt it. And you miss me so much. It makes sense. I get it. I get it. All right. Let's expand this logarithm then. So first thing that I attempt to look for is, can I simplify inside the logarithm at all? Right. Let's just look on the inside and say, can I do any type of canceling? Can I do any simplification? In this case, x, I can't do anything with the x. Y, there's nothing that I can cancel with the y. Same with z, same with h. Okay, so in this case, no, there's nothing I can do to simplify. But always check to make sure, because it could help you out. So let's expand. Again, like I said on the first expansion problem. Okay, first deal with or first address division. Okay, whenever you are expanding. You don't absolutely have to, but it's a good rule of thumb. So stuff from the numerator goes first in the first logarithm. Division gets split up as subtraction. And then stuff from the denominator is what goes inside of the second logarithm. Now, both of these logarithms have multiplication inside of them, so I'm going to have to split up both eventually. It's your choice as to order. I would say just go left to right. It's the easiest way to go about it. So multiplication gets split up as addition between the logarithms. And I'll go ahead and split up this one right now too. Okay. Now, there is something important that we should do here. Besides just the splitting up, since this is a minus sign, then we have to be super careful about whenever we split this up, what actually happens, right? Because this one logarithm became two logarithms, but it's still the same thing. It represents the same thing. So I actually want to put some sort of brackets or parentheses around these because this minus sign should be distributed to both of the logarithms. All right, so when you split up a logarithm after a minus sign, or even in general, I mean, it wouldn't hurt us. It doesn't change anything if we, if you just want to make it a good practice to yourself to whenever you split up a logarithm, you always put parentheses or brackets around it, then great, do that. But especially after a minus sign, because we have to have that minus being distributed to both any components that are inside of that. Oh, I'm freaking out. Oh, okay. Log base 2 of x plus log base 2. I'm going to go ahead and make a change here, just like last time. Instead of square root of y, that would be the same thing as y to the power of 1/2. Since I know my goal is going to be, if I have exponents, to move them down, then I know that the square root of y can actually be written as an exponent, so it'll help. Minus log base 2 of z cubed minus log base 2 of h squared. And then very last step, just like before, take our exponents and let's use our property to bring them down. So log base 2 of x plus 1/2 log base 2 of y minus 3 log base 2 of z minus 2 log base 2 of h. Yeah. So there it is. It's just using those properties. Again, practicing using them. We're going to use them more usefully, not just for like, well, great, expanding and condensing. How does that help me? We're going to use them more in, we need them to solve certain types of equations. So we'll use those properties a lot. But otherwise, so now I guess now would be a good time to talk about just kind of class and school in general. So I know things. There's not. I don't know how much details you've heard or that you know, but as far as this class is concerned, my plan is, like I said, I'll be here at this time to do the notes that I would have normally done in class, but just via Twitch and upload it to YouTube each afternoon as well if you missed the stream or whatever. But would please encourage you to attend the stream. And other than that, I don't know exactly. We have a staff meeting this afternoon. Hopefully, find out more details. But I don't know what PFAs or performance tasks or projects are going to look like. I know that they're still a thing. You're still going to have to pass your PFAs just like you normally would. I just don't know what the specific plan will be in the protocol. I mean, it'll basically be you taking them at home, but I don't know if there'll be like a certain time frame open or where you can do them, or there's been talk of like maybe sending notes or things like that. I don't know. But I'll let you know whenever I know more stuff too, and what our class would look like. Luckily for this unit, I already wasn't going to have a performance task. This is one of the rare cases. I actually have a project that I made last year that we're going to use again this year for math analysis. So that'll be good. That'll be something that I can send to you, and that you can do at home. That it wouldn't have been a typical testing situation, anyways. If we were at school, I would have had you like work with a partner, but since we're not, then we won't. But that'll be okay. Otherwise, yeah, I don't know. When we eventually get to a performance task point, I don't know what that's going to look like yet. Hopefully we find out some more information, some more details today. But I don't know. Do you guys have any questions for me about this lesson, or about class in general, or about school in general, or anything like that? It's been pretty quiet in here most of this lesson. Is this going to all be on YouTube? Yeah. So, yeah. Here, actually, this is good. I was going to show you guys anyways. You mean my daughter? Okay. Sorry, give me a second. I'm pulling this up. Okay, so to answer the first question of, is this going to be on YouTube? I was in a conference with Mata. Sorry. Yeah, right. Nice try. So this, hold on, if I can get this to work. Come on. Miss bullying you in real time. Well, we all have to make sacrifices in these trying times. Yours will be that you have to wait and just bully me, through normal text chat. Unfortunate world we live in. Okay. This isn't coming up, but whatever. Yes. So, anyways, to answer your question, I was going to show you the actual thing, but to answer your question, yes, this will all be on YouTube. This is my last class that I teach every day. So once I'm done here, then I just have to I'll have to download the video from Twitch and then upload it to YouTube, which doesn't take a hugely long time, but I also have to do it for my other classes. But so by late afternoon every day, maybe evening, they should be uploaded to YouTube. Yes, if in case you miss it for something, or if you just want to go back to look at something, just go to that YouTube link, the channel I sent you guys, and I'll continue to send you. If you go to that and then just click on playlists from my YouTube channel, there's a specific playlist from each class. So a playlist for my second block college algebra, for my fourth block, for calculus, for math analysis. You'll see it there once they're all uploaded. So yes, they will all be on YouTube. Okay. How do I print the notes with Smart Notebook? You mean like actual print, like you have a printer that you want to print them off of? Is that what you mean? Okay. Yeah, so if you go to File, if you're on Smart Notebook and you just click File, Print, then you can do one of two things from here. So first off, you can change how big you want everything to be. So that where it says thumbnail size in the middle, you can do large, you can do full page. So if you do full page, every single slide will become a full page of the paper, or whatever. You can mess with that. But then it should just be that you click print from here and it works. Now you might need to check printer setup, because your other option is you could, the first option that's listed right here is you could print it to a PDF first. Sometimes printers are weird with connecting to Smart Notebook, but sometimes they're better about printing from just a direct PDF file. So if you want to print it to a PDF first and just save it to your desktop or something, or wherever in your files, and then open up the PDF and print that, or otherwise, if you had a printer connected to your laptop, then it should show up here, I guess, somewhere. I'm not sure. If maybe it doesn't work from your school laptop, maybe from your school laptop, print it to a PDF and then send that PDF to a different computer in your house, email it to yourself on a different computer in yourself that will print it well. Those would be my best options, if that helps, maybe. But if not, please let me know, or email me, or keep asking me questions now, and I'll try to help you fix that. Okay. I miss being away from my family. Okay. I will continue to be here for a while again. So I have, at least the way I have it planned right now, and maybe it'll change, but I'm just kind of test running this, see how it goes. But that every day after this class, I just have office hours. So I'll still give you guys homework assignments like I normally would sometimes. I'm not going to collect them, obviously not in person. Unless I'm told otherwise, in a meeting or something, I'm not going to have you take pictures of your homework and send it to me just to prove that you did the homework. Maybe we'll have to do that for projects or performance tasks, things like that. But I don't want to have to do that 2-3 times a week just for homework assignments. It seems absurd. So I'll still send you assignments sometimes, some days, and it'll just be, I mean, just like in general, it's not like the homework counts for anything, but it's something that you should still be doing definitely to get the practice, because you will still have to do performance tests and PFAs somehow. I don't know how yet, but you will still have to do them some way. So might as well have and do the practice. Any other questions? Anything? Again, about school in general, class setup.